Okay, our last subtopic, which is on application of motion of charged particle. So in this subtopic, you should be able to explain the motion of a moving charged particle in magnetic field and electric field for velocity, magnetic flux density, and electric field perpendicular to each other. And lastly, you have to be able to use velocity in a velocity vector. For example, a Bainbridge mass spectrometer. Okay, so let's consider a positively charged particle with mass m, charge q, and velocity v enters a region of space where the electric and magnetic fields are perpendicular to the particle's velocity. Okay, so this is the velocity, and the magnetic force is perpendicular, as well as the electric field is also perpendicular to the velocity. Okay, so the charged particle will experience the electric force downwards with magnitude QE. Okay, so remember the electric force is equal to QE, and the magnetic force is upwards with a magnitude of QVB. Okay, so if the particle travels in a straight line with a constant velocity, the electric and magnetic should be equal in magnitude. So FB is equal to FE, hence we'll then get the equation V equal to E over B. Okay, so only the particles with velocity equal to E over B can pass through without being deflected by the fields. That's why it is known as velocity selector. Okay, so the equation above only works for electron or other negatively charged particles lah. Okay, if positive, they tidak work. Okay, so normally after the charged particle pass through the velocity selector, it will enter the next region, which consists of uniform magnetic field only, which is known as the mass spectrometer, as shown here. Okay, so when the charged particle enter the region consists of magnetic field only, which is this one, it will make a semicircular path of radius r. Okay, so again, this would equal to the magnetic force here would equal to the centripetal force. Okay, so from there we can then get this equation here. So this equation can be used to determine the value of Q over M for any charged particle. Okay, so this one can be used for any charged particle. Okay, alright, so that is the end of our chapter number 4.